Hi everyone, today we have an example on solution stoichiometry. So solution stoichiometry is actually going to be very similar to normal stoichiometry with one change. We're going to use molarities in this type of stoichiometry. So first thing with any stoic, we would actually need to write down our given and required. So if I look at what volume, so that's a question for me, of zero point 0.4 molar H3PO4, it's asking me to find something out about that. The other thing given to me in the problem is 433 milliliters of 0.21 molar NaOH. So givens and requireds, easy way to tell with solution stoic which one's your given is to be a given, it has to have both molarity and volume. So on the right side, 433 milliliters, that's a volume, of 0.21 molar, that is a molarity. So if we have volume molarity, it can be a given. On the left side, 0.4 molar H3PO4, that's missing a volume, so that can't be a given in this particular case. Givens still could be grams, they could be moles, so that would not change at all. But for right now, given in this case is going to be 433 milliliters of 0.21 molar NaOH. I'm going to convert that right away into liters. Notice I did include the molarity along with it. Required is going to be liters of 0.40 molar H3PO4. Notice in these cases I'm including the molarities in both. Now the required said what volume. How did I know to pick liters and not milliliters? We're always going to pick liters unless told otherwise. Now I said in solutions stoic we're going to be using molarities. So now we have to be able to break molarities apart. But first, just a reminder, molarity is going to be moles over liters. So in the given, I had a molarity of 0.21. So I had 0.21 molar. Now to break this apart, something I can do is write on top 0.21 moles. On the bottom, I can write 1 liter. So if I would take 0.21 divided by 1, it would still equal 0.21. So that is breaking up the molarity for, this is for NaOH. Now, for the required, we have 0.4 molar H3PO4. I was going to rewrite that. 0.40 moles over 1 liter. And this is for H3PO4. So notice both cases, the volume ends up being 1 liter on the bottom. That's okay. That's going to be opposite of moles. So this is something new, breaking up molarities. And that's going to come into play in our solution stoic. So we have our given and required. So let's go ahead and write that out. So we have 0.433 liters of 0.21 molar NaOH. First part of any stoic problem is going to be converting into moles. So to convert this into moles, I'm going to need a mole on top. And currently, we're in the unit of liters. So we need to get out of liters, that makes it be on the bottom. Now take note, we have moles on top, liters in the bottom. If I look over on the right, I have moles and I have liters. I'm also working with NaOH. So I can use this broken apart molarity to convert into moles. So if I look to the right, I see 0.21. 0.21 moles goes on top, and this is moles of NaOH. On the bottom, 1 liter of NaOH. Canceling out now units. So now I'm currently in the unit of moles of NaOH. Once I get into the unit of moles, I can use something called the mole ratio. So moles of NaOH needs to go on the bottom in order for it to cancel out. My required is a substance of H3PO4. So moles of H3PO4 is going to go on the top. Coefficients, got to look back at the balanced equation. I see a 3 up top for NaOH. There is nothing in front of H3PO4, which means it's a 1. So I have 1 over 3. Next thing I can do is cancel out my units, moles of NaOH, moles of NaOH. So currently I'm in the unit of moles of H3PO4. However, I was required to go into volume, so I have to go one more step. I'm going to do a little rewriting here to give myself a little bit more room. So I was in the unit of moles, except I don't want to be in moles anymore. So moles is going to have to go in the bottom in order to cancel it out. On top, I want to go into the unit of liters. So liters over moles. And just a refresher, we're in H3PO4. That's the substance we are working with right now. So, taking a look back, H3PO4, that was over here, right? H3PO4. We actually broke up the molarity of H3PO4. Now in this case, I had 0.40 moles over 1 liter. However, when we're using a molarity in a solution Stoich setup, it is okay to flip this if need be. So if I look back down below, in this case, liters is on top, even though up top right, liters was on the bottom. That's okay to flip it. And on the bottom, we have moles. And if I look back to the right, I had 0.40 moles. Now this is both H3PO4. So once again, this is the broken up molarity. However, in the Stoich setup, it is okay to flip around the molarity equation, you could say. Cross off units. So right now I'm in the unit of liters of H3PO4. That's what I want it to be in. And now I'm ready to solve it out with multiplication. So I end up getting 0.0758 liters of, liters of 0.40 molar H3PO4. So Stoich really isn't that different in this particular case. However, if I was going to highlight two things, this step right here is new because it's based off the molarity of H3PO4, because that's what we're going into. The other new step is right here. So we were in liters of NaOH, and to get into moles, we had to use, once again, the molarities. So the molarities need to be broken up to be used within the solution Stoich problem. So the two highlighted things, these are our new steps in Stoich. Otherwise, the Stoich process stays the same.